Hello everyone, Mr. Fawcett back here, and we are about to start part 2 of our lesson on algebraic proofs. In the previous video, we went through some of the different properties that you're going to use for the justification column for your proof. So we scroll down, you should have all these properties filled in. It may be a good time for you to review these before we start working on some practice problems because you're going to be using them heavily throughout the rest of this lesson. That being said, let's get started. We are going to start with proof number 3. You'll notice that this time you're writing the entire proof. So you're not only doing the statements, but you are doing the reasons as well. Again, might be helpful for you to take a look at the proof above. Look at what we put in the statements column. Look at what we put in the reasons or the justifications column. In the statements column, you're going to have the algebraic work. So you're taking this equation right here, right? And you want to solve and show that y is equal to -2. So all that work is going to go in the statements column. You need to show every single step. In the reasons column, you need to then tell me what property or definition that you were using to go from one statement to the next. So pause the video, take some time to attempt that, and then come back and see how your work holds up. All right, so I put the work up, and now we're going to talk through it. As usual, in your proofs, you're going to start with whatever is given to you. So we were given the equation 5y plus 4 equals 3y. That's going to be our first statement. That's going to be what we're working from. And the reason for that, right, is just given. That's kind of a freebie. You don't have to think of any special reason, property, theorem, definition. You can just write given. The next line, to go from first statement to second statement, I subtracted 5y from both sides. Right? So you could think about how to do the math. You don't have to write minus 5y in your proof. You just show what you get after you subtract 5y. And then, of course, you come over here and you write subtraction property of equality. A reminder from last video, we can abbreviate property of equality, POE, because you'll be writing otherwise, you'd be writing property of equality quite a bit throughout your proofs. Third statement, to get there, we divided both sides by -2, and that would be the division property of equality. Now, we have an answer here, but we want it to look exactly like what we're supposed to prove. Right? So we want to prove that y is equal to -2, so we're just going to use the symmetric property to flip that equation around, to swap both sides. So if -2 equals y, then we know that y equals -2 by the symmetric property of equality. You'll notice that you didn't use all the rows in your proof. That's fine. Many times I give you more than you need. It's also possible that you could have solved this a different way and used more steps. So maybe you started off by subtracting 4 from both sides. That's okay. You're allowed to prove things in different ways as long as you justify each and every step. This is just one way of proving that y is equal to 2. All right, let's see the next proof that's on deck for us. Okay, this one's a little different, so we kind of have a word problem here. It says the equation below converts between Celsius and Fahrenheit. If the temperature is currently 86 degrees, we need to prove that it is also 30 degrees Celsius. So think about what you're given. That may be what you write down in your first statement column. And then think if you can work from what you're given to 30 degrees Celsius, because that's what we want to end up with, right? If we start at 86 degrees Fahrenheit, how can we show that it's also 30 degrees Celsius? So go ahead, pause the video, take some time, and then come back and check your work. Okay, so there were actually 2 pieces of given information here, and you can put these in the same box, or you can put them in separate boxes. It doesn't matter. I chose separate boxes because I didn't want everything to look a little squished. So the first thing they give us, or one of the things they give us, is the equation, right? That's given to us, so we're going to use it, so we need to write it down, and we can say that it's given. They also tell us that f is equal to 76, And they do that with this line right here. It says the temperature is currently 86 degrees Fahrenheit. So F stands for the temperature in Fahrenheit, which means F is equal to 86. Now, if we want to figure out what the degrees Celsius is, then we need to substitute 86 in for F in our equation, right? So that's how I went from these two steps combined to this one. We use the substitution property of equality. Once I substituted, all I had to do was simplify the right side of my equation. I didn't have any inverse operations to do. And once I simplified, that whole side simplifies down to 30. Now, if you wanted to break that simplifying process up into two steps, you certainly could. For instance, if you wanted to do something like this, you could do C is equal to 5/9 times 54. And then you could have one more step that says C is equal to 30. So you would just have one extra line in your proof, but there's nothing mathematically wrong about that. If you think that's going to keep you from making a mistake, go ahead, go for it. You just need to make sure that what you end with looks like what we were trying to prove. So that C is equal to 30. All right, let's move on. And we are now going to start, we're kind of going to bridge the gap between the algebraic proofs where we're given an equation and asked to solve to some geometric proofs where we're going to start using some geometric concepts. So for some of these, I kind of gave you, because we haven't looked at all the geometric properties that we're going to be using yet. So I'm going to kind of give you those for this lesson, but this is kind of a bridge between what we were doing in the early parts of this lesson and what we'll be really focusing on next lesson and throughout the rest of this unit and course. So it says complete the proof below to solve for x. So our goal is to solve for x. They don't necessarily tell you what x is here. They may or they may not. In this case, they don't. So we just need to prove that x is equal to whatever value it is equal to. We don't know what that value is, but we're going to show each step so that we know for sure that our answer that we get is correct. The first thing we have to do is we have to come up with an equation, right? The only thing given is the diagram, but the diagram has no equation on it, right? It just shows us that there's this segment. It's broken up into two smaller pieces, and those together equal the larger piece. So if we think back to one of our earlier lessons in the first unit, if we break a segment up, the lengths of the two pieces will equal the length of the whole. So that's right what we have here, right? This piece right here is the whole segment, and these two pieces right here are the parts. So if I add the parts together, that should give me the whole. Now, this idea is called the segment addition postulate, so that's going to be our reason here. Okay, let's see. You can pause the video here if you think you know what to do. You're obviously going to have to make some substitutions, but yeah, I'm not going to say too much more because I want to let you think if that's the path you want to take here. So feel free to pause, think about what some other statements you could come up with are. I will say that we haven't written down a given yet, so you can go ahead and think about what the given would be. I'll give you a hint. It has to do with Km, Kl, and Lm. But other than that, I'll stop here and then come back when you're ready to check your work. Okay, so for our second statement, I wrote down the givens. So our first statement I gave to you because I didn't know if you'd be able to come up with it at this point in our curriculum. So the given does not have to come first. The given can come wherever you need it to come. But I had to put the given here so that then I could use it here. So I wrote down the given. That just told us what the expressions for each of those segments or pieces of the whole segment were. And then I substituted them into the original equation that I gave to you. So we are using these two, oops, let me get my pen. We use these two statements here to create this one. So we came up with an equation, we defined what each part of that equation was, and then we made some substitutions. Then I just used some inverse, well, I guess first I simplified. So I simplified the right side of my equation. I combined my x terms and I combined my integers. So I did some simplifying right here. Then I started to use some inverse operations to get x by itself. So I first subtracted 3x from both sides. That was the subtraction property of equality. I then added 4 to both sides. That would be the addition property of equality. And then I divided both sides by 2 for the division property of equality. Okay, we have one more proof to do, and then we're done with this video. So we have another diagram here. It says given the measurement of angle ABC is 180, and the measurement of angle ABC equals the measurement of angle ABD plus the measurement of angle DBC, write a proof to solve for the value of n. So we're taking, this actually has to do with the angle addition postulate. So we have this straight angle right here, right? And what they're saying is that these two pieces of the straight angle should add together to equal the entire straight angle, right? So I give you an equation this time, and I give you some expressions for the red and the green angle, as well as telling you what the measurement of the pink or the straight angle is. So see how far you can get in this proof. At the very least, because this is always worth kind of free points when you're doing a proof on a test or exam. You should always write down the given. So if there's anything given, write that down. That's going to earn you at least a couple points here and there for your proofs. Even if you're unsure of what to do with it, put it down if you know that it's given, and you'll earn a couple points. All right, so I had to make these rows a bit skinnier just so I could fit everything on the page. Remember, you also can put your givens. You can split those up. Again, I crammed them in just because I needed to keep everything on the page so you could also see the diagram at the same time. So again, first thing that I put down is I wrote down the givens that were up here. Okay, I put those in this statement column. Reason was given. For my other givens, I came over to this diagram, right, and I looked at, I think I'm going to need to erase these so you can see them better. I looked at what each angle's expression was. So for DBC, this angle right here, right, that angle has an expression of 4n plus 22. So we wrote that down. And then for angle ABD, well, that had an expression of 8n minus 10. Okay, and again, those were both given because we saw those in the diagram. Once I had everything that was given written down, I combined my equation and the individual measurements using substitution. So I took the equation we have right here, right, and I substituted all of these values in for the different angle measurements. So I took these two statements and I combined them into this one. Then I just used a combination of simplifying and inverse operations to get my n by itself. So I first simplified the n terms and the integers on the right-hand side to get what I have in blue. I then subtracted 12 from both sides to get what I have in pink. I then divided both sides by 12 to get what I have in green, and then just because I wanted it to look more formal, I used the symmetric property to get n on the left-hand side. So instead of 14 equals n, I said n was equal to 14. That's going to wrap it up for this video. So again, if you're still a little confused on proofs, that's okay. Maybe watch the video another time. Work through these proofs on your own again. A lot of times you can do proofs multiple times, and you're still going to learn something each time you do it. Next lesson, we will move more into some geometric proofs, so dealing more with geometry rather than just strictly solving equations, but you'll still be using these properties quite a bit, right? Because in geometry, we may be given a diagram, just like we are here, but that still is going to involve us solving some type of equation a lot of the time. So I look forward to seeing you next video. We'll dive more into these things called proofs. Until then, though, enjoy the rest of your day.